Yeah, it's running.
Okay, great.
Good afternoon, everyone. I'm going to keep it very, very short because Antonin is becoming a well-known feature in our PGG sessions. This is number 3, right? Third time, well, I was going to say third time lucky. No, good luck goes in 3s, right? Last time you talked about epistemology, what is knowable at all. And this time the title of your follow-on from that is From Information Theory to a Theory of Everything. Antonin, over to you. Thank you very much.
Thank you very much, Liz. So I see a couple of new faces here. For those who don't know me yet, my name is Antonin Tuinman. I've been working here as an examiner for 18 years now in the field of biotechnology in the group of clinical diagnostics. But I also have a hobby of philosophizing. And in fact, as Liz already said, this talk is the sequel to a previous talk with the title Epistemology, What Can We Know at All? And together these two talks reflect the essence of 2 books I wrote. The first one is Technovedanta 2.0, which has a crazy subtitle, which is Transcendental Metaphysics of Pan-Computational Panpsychism. And that's more or less what this talk will be about, so beware. This book I wrote alone, and I wrote another book, a little bit in the same spirit, which is called Is Reality a Simulation? An Anthology. And this one I co-authored. There are 10 authors in total, and I edited this book as well. So in my previous talk we were exploring the foundations of knowledge. And I remember that Jan Helberg asked, did we get any further from Descartes, cogito ergo sum? I think therefore I am. Is that all we can know for sure? And I also told you that if we apply a scientific method based on empirical observations, we're always left with a certain level of uncertainty. We're always interpreting data. We don't really know for sure whether our interpretations are correct. But there was a promise of me that in this talk I would look for a more solid foundation of knowledge. And such a foundation can perhaps be found in a combination of information theory and what physicists call string theory. Now, string theory is a candidate for a so-called theory of everything. And when I will be talking about string theory, I include all successor theories to string theories, such as the superstring theory and also the M theory, which is also called brain theory, from membrane. Good. So now we have to explore what is the most fundamental in existence in order to come to knowledge. And for many centuries, scientists and philosophers believed that matter was the most fundamental thing in existence. Already in the 5th century before Christ, Democritus declared, nothing exists except for atoms and empty space. But with the advent of Einstein's E is mc square equation, which finds its application in nuclear plant technology, it was actually shown that we can transform matter into more subtle forms of existence, like for instance electromagnetic radiation. And also, if you are transmitting information via Wi-Fi between the sender and the receiver, there's no material carrier. The information is transmitted as patterns of electromagnetic waves. So there is something more subtle than matter. But there was an interesting word in this last phrase, and that word was information. Because the physicist John Archibald Wheeler wrote an article called It from Bit. And in this article he argues that information might be more fundamental than matter or energy. And this may be a very useful piece to explore in our quest for knowledge, because the neuroscientist Giulio Tononi links consciousness to the so-called integrated information theory. And he believes that consciousness arises when information is integrated in a feedback loop manner. Now that consciousness is important in our talk is immediately evident because we are looking for the foundations of knowledge. And if we can know anything at all, it is because we can be conscious of it. Because if information is just hovering around at a subconscious level, we don't really know it, do we? And physicists, with their string theory, they are actually looking to unify forces like gravity, electromagnetism, and the nuclear forces. And they also try to unify the world of the ultra microscopic of the quantum with the ultra macroscopic of relativity theory. But when we, as laymen, hear the word theory of everything, we would like it to be something that explains everything, including the phenomenon of consciousness, for which physics doesn't have a conclusive explanation yet. So perhaps because if John Archibald Wheeler is right and information is the most fundamental thing in existence, and if Giulio Tononi is right that the integration of information in a feedback loop manner leads to consciousness, that could build a bridge between physics and consciousness. Now, what is information? To us, it can be the answer to a question. It can be a message carrying a certain meaning, and it resolves a certain uncertainty. But I say to us, because to computer scientists, it means something slightly different. And I'll come back to that later in this talk. So whenever we try to transmit a piece of knowledge to somebody else, we encode this information. For instance, we write it down in a written script, or we put it in Morse or a telegraph code, or we speak it in words. But in fact, all these things, written script, words, they are means to encode meaning. And we actually suppose that the receiver uses the same dictionary as we do, because only then can there be an understanding. And this is also where it sometimes goes wrong, because if the dictionaries don't match, if people give another interpretation to a word you use, they might misunderstand you. So that's the problem of the meaning which is conveyed. Now, what is meaning? Meaning is what the information signifies, what it represents. And it can represent mental concepts, it can represent physical facts, it can represent emotional states. And on the one hand, we express this meaning in terms of all kinds of features, with all kinds of relations, a little bit like a claim. And on the other hand, what happens within the person who receives the information is that a certain feeling is evoked. Now, whenever we encode information, and also when we decode information, it seems like we need some kind of intelligence to do this. And this is not only happening at the human level of social interactions. Animals can also signal each other. They have all kinds of behavior, they can make sounds. And even plants can sometimes be able to communicate with each other. There are plants who, via their roots, communicate with each other because there's a network of mycelium, of fungi, that connects the roots, and there are molecules sent via the mycelia between the plant roots. And also, in an organism, we have all kinds of informational processes going on. Normally, we have these hormones, which are signaling molecules, which make the organs communicate with each other. And then within a cell, a lot of things are going on. A cell is a huge information processor. There are countless molecular pathways with all kinds of processes where molecular moieties are joined and cut off. And these are all called messaging pathways. And in fact, they are orchestrated by a kind of computer in the cell, which you probably all know of, the DNA molecule. And the DNA molecule is transcribed in a very similar molecule, which has a very similar code, which is the RNA molecule. And this RNA molecule then finally leads to the translation of that information into the synthesis of proteins and peptides. Now it may sound a little bit strange to speak about cellular intelligence or to think that a cell understands what it is doing, but given the fact that a cell can maintain its homeostasis under a wide variety of environmental conditions, it shows that a cell is doing something more than a mere clockwork mechanism. So I was speaking about the DNA as a computer code, and in fact it's a code which has 4 symbols, which are molecular moieties, here indicated with a T, C, A, and G. And a T can pair with an A and a C with a G, and in that way you can make them match. And an RNA molecule, which I spoke about, can also dock to this because they have almost the same symbols, and it can be copied, and all kinds of computer-like processes take place on the RNA level. But the quaternary code is not the most simple way to encode information. The most simple way to encode information is a binary code. And you probably all know that in a computer we represent a binary code with 1s and 0s. And it doesn't mean that 1s and 0s are literally jumping around in your computer, but rather it is the most simple way to express information, and that is in a difference. So you have always 2 states. So the 0 can, for instance, be a low voltage on a chip, and the 1 can be a high voltage on a chip. But if you are using glass fiber technology, you can do it with light pulses. So certain patterns of light pulses can be the 1s, and other patterns of light pulses, or the absence of light pulses, can be the 0s. And this is because information doesn't care how you encode it. You can encode exactly the same information with smoke signals, like the Indians did, with telegraph, with Morse, with sounds, with light. It doesn't matter, because information is essentially substrate independent. Now that's an interesting thing, because on the one hand, information needs a kind of physical carrier in the form of matter, or in the form of something more subtle, like electromagnetic waves. But both of them are physical. They are in the realm of physics. But on the other hand, information has also a kind of metaphysical component, in that it is substrate independent. So it is independent from the type of physical carrier that you use. Now, computer scientists went a little bit further. Forget about meaning, said Claude Shannon in 1949 when he presented his information theory. Now that's a big thing, because for computer scientists, information is a measure of the amount of pattern present in a set of signals or symbols. For instance, if you have a string of 100,000 alternating 1s and 0s, now if you would have to transmit that information by sending each 1 and 0 at a time, that would cost a lot of time. But you can transmit exactly the same information by compressing that information hugely by writing a very short algorithm which says 1, then 0, and then repeat the previous 49,999 times. So in a very short algorithm, we have now compressed exactly the same information for which we otherwise would have needed 100,000 symbols. And for Claude Shannon and the computer scientist, it was that if there is a lot of pattern present in a string of symbols, there's actually very little information in it. Whereas if there is a lot of information present in a string of symbols, there's actually not so much pattern there. But there are patterns anyway, because otherwise it's not really informational. Now there is a very interesting development in physics these days, which is called digital physics. This is a terminology coined by Edward Fredkin, and he also speaks about digital philosophy. And it is shown that there are many processes in reality which actually appear to be encoded by a binary code. The Dutch physicist Verlinde showed that if you cover a sphere with ones and zeros, you can mathematically deduce Newton's law of gravity from this. And he is not the only one. We have John Archibald Wheeler, of course, but we also have Konrad Zuse, we have von Weizsäcker, we have Sissi, Wolfram, Tekmark, Van 't Hooft with his holographic principle. He believes that the world is a kind of holographic projection of a kind of binary code. And we have James Gates here in the top right corner. Now, James Gates studies string theory. And string theory describes all the subatomic particles which make up the whole of the material world, and also the particles which are used in electromagnetic radiation, such as photons. And what did James Gates discover? He discovered that buried in the equation of string theory, there is a binary code, a computer error-correcting code. So the whole material world, all the subatomic particles are somehow described by a binary computer error-correcting code. That's freaky. That makes us think of the film The Matrix. Are we living in some kind of computer simulation, one could ask? But there's also something more interesting here. In my previous talk, I told you, well, if we apply our scientific method, we can never get further than interpretation because we always need empirical observations. And even if we do deductions, our deductions always have a premise. And the premise, for instance, all men are mortal, is based on an observation. We never saw somebody live on forever. But here we have perhaps a more solid foundation for knowledge. Because if we can mathematically deduce the whole of the physical world and all the laws of physics from the interplay between digitality and geometry, then we really have a solid foundation for knowledge. But there is a caveat here. We must be careful because what we are doing at this moment is still a little bit of abductive reasoning. The fact that the grass is wet doesn't necessarily mean that it has rained. The fact that we now have found that certain laws of physics can be deduced mathematically from the interplay between geometry and digitality does not necessarily mean that all laws of physics can be found in that way. But the evidence is mounting over time, so this becomes more interesting, and interpretations such as we might be living in a computer simulation or the world was made by God mathematicians then become more attractive. And of course we would like to know, is this world real or are we just encoded by some information? And therefore we must seek if we can answer the question, can information exist without having been encoded by something above us, by a higher society of higher developed entities? Can information exist in and out of itself? And in order to answer that question, we first have to answer another question. Can anything exist at all without informational content? Let's do a thought experiment. There's a pure nothingness. And now we want something to exist. Now the Latin word existere, which is the etymological root of the English word to exist, actually has two parts. Ex, which means out, and sistere, which means stand. So it means to stand out. Now in order to stand out from an otherwise homogeneous background of nothingness, there must be some kind of difference, isn't it? And already by having a difference, we create two states. So we create already the basics of information, of binarism. And there is a very interesting experiment in physics which is called the Casimir experiment. And you have two electrically charged plates, and between those plates you make a vacuum. And then it's shown that from the vacuum, spontaneously subatomic particles like electrons sprout into existence. Whoa, that's a strange thing, because from Shakespeare we knew that nothing shall come from nothing. And yet here it appears that it does. Well, in fact, a vacuum is not a real nothingness. The vacuum is still filled with electromagnetic waves. So then we must ask ourselves, how can electromagnetic waves configure themselves so that they can stand out from an otherwise homogeneous background of waves? And that is possible, because we have to make a little jump to wave dynamics. And as you may know, if you throw two stones into a pond, they make these circles around themselves, and at a certain point these circles start to overlap, and then at certain positions they start to reinforce each other, here indicated with red, maximum intensity, and at certain points they start to cancel each other out, here indicated with blue, minimum intensity. And then you get this kind of pattern. So this is a constructive interference pattern. Now, there are even more interesting constructive interference patterns, and they are the so-called standing waves. And this is what happens when you pluck a string on your music instrument. And when you hear a pure tone, this is because exactly a whole number of waves fits exactly on the length of the string. Now, in string theory is our candidate for a theory of everything. And string theory was also encoded by some binary code, the particles. String theory describes all the subatomic particles, and in fact these subatomic particles in string theories are, let's say, circular strings which are in a kind of resonance, where we also have a standing wave. And this resonance occurs when exactly a whole number of waves fits on the length of the string. Whereas if it doesn't exactly fit, you don't get a particle. So somehow subatomic particles can come into existence if the wave somehow folds back onto itself and matches so as to form a kind of resonance pattern. And this is very interesting because all subatomic particles therefore have wavelengths, and they have a certain amount of waves, and they have a certain amplitude, so they are actually numerical entities, they are informational entities. This reminds me of a symbol from alchemy, which is the Ouroboros. And here we get perhaps a link towards consciousness. Now the Ouroboros was a symbol of a snake who bit itself in its tail. And it was usually interpreted as being symbolic of the eternity and also of the cyclical nature of reality. But it was also a symbol of consciousness, because the snake didn't know when it saw its tail that it was part of itself. So it was exploring that tail, and he thought, nice piece of meat, and he bit in it. And then, of course, he jolted, and he realized, oh my God, this is part of myself. So he became aware, he became conscious. And what we have in our subatomic particles is also something like that. It's a snake that bites itself in the tail, and thereby forms a kind of self-sustaining, self-generating feedback pattern. Keep that in mind. Now, in many religions, it's often suggested that the theologists say that God exists completely outside of the physical world. There's nothing physical about God. God is purely metaphysical. But we have just seen that in order to exist, we need to stand out from a background of nothingness or a somehow homogeneous background. In order to exist, there must be a difference, there must be some information, and that is always physical in a certain extent. So a God which is purely metaphysical and has no physical component seems to be something difficult to understand to me. Now, we may have explained the material world in terms of information with these self-generating, self-sustaining feedback loops of the subatomic particles. But what about consciousness? We still haven't explained that. And the interesting is that there are a number of philosophers and scientists who have suggested that consciousness also involves a kind of self-generating, self-sustaining, self-referential feedback loop. And one of those philosophers is Douglas Hofstadter. Perhaps you have read the book Gödel, Escher and Bach, which is one of his books. And he uses a drawing from Escher where two hands draw each other into existence to explain this more or less paradoxical idea of a self-generating, self-sustaining, self-referential feedback loop. And also Giulio Tononi, who has the leading theory on consciousness these days with his integrated information theory, he believes that if information is integrated in a feedback loop manner, that's when consciousness is involved. Now that's not such a strange thing, because for instance you see an object somewhere and you want to know what it is and you don't clearly know what it is, so you focus your attention on it and information comes back from the object, light pulses go into your eyes, into your brain, and in your brain features are analyzed, they are integrated, and when a match is found with a mental concept you already had, when the features match, there's an integration taking place, so there's feedback from the object you wanted to observe, and the information loops into a mold of the concept you have in your mind, and when that fit is made, recognition occurs, and then you become aware of the object. But it can go further than that. Not only can you be aware of the object, you can then also become aware of you being aware of the object. So you're aware of your object awareness. That's another loop. And then you can make yet another loop, and that is being aware of your awareness as such. And every time you make such a loop, you become more focused and you have more attention. It's actually a kind of meditative technique. So perhaps it's not such a strange thing to suppose that consciousness involves also this kind of self-generating, self-sustaining, self-referential feedback loop. Perhaps we can even turn it around. Perhaps having a self-generating, self-sustaining, self-referential feedback loop is a hallmark of sentience or consciousness. If that is true, then maybe our subatomic particles, because they are also such loops, they are resonating with their own vibrations, perhaps they are also sensing their own resonance, and perhaps they are also sensing their direct environment. If that is true, then perhaps the whole world is in a certain way sentient. And that would lead to the notion of panpsychism. Everything is psychic, everything is sentient in a certain way. And the Greeks and the Romans already had that idea. The Greeks called it heliotroism. Now, I don't mean with panpsychism that the chair which is standing here is aware of being a chair. I also don't mean that this glass is aware of being a glass. I just mean that the subatomic particles that make up the matter of that glass may be aware of their own presence to a minute extent and may be aware of their direct environment. And I also don't mean that our consciousness, our human consciousness, is the sum of those subatomic particle consciousnesses. That's an absurd idea. But whenever there is information integration taking place in a feedback loop manner, and that can also happen at higher levels of existence, such as ours, then something of a higher level of sentience or consciousness can arise. Now, is it really an idiot idea to suppose that subatomic particles can somehow sense? Well, actually there's an experiment in physics which is called the double slit experiments, which suggests that they are to a certain extent sentient. In the double slit experiment, we send subatomic particles to a screen. This is the screen, and this is actually a projection of the screen. So I flipped it 90 degrees here so that you can see where the particles can land on the screen. But before they reach this screen, they have to traverse another screen. And in that screen, there are two slits. Now, what you would expect, because for instance, photons are subatomic particles, if a photon follows the laws of optics, it travels in a straight line, isn't it? So you would expect it to land at these two positions, two lines. But what you see is that you get multiple lines as a pattern. Now that's an interference pattern, and that's something we knew from wave dynamics. So you could say, okay, perhaps these subatomic particles have both a particle and a wave type nature, and when two particles traverse the slits at the same time, they might start to interact with each other and thereby create this interference pattern. But even if you slow down the sending of these particles such that one particle at a time is traversing the slit, you still get the interference pattern, or at least they land at a position corresponding to one of the positions of the interference pattern. And now it gets even weirder. You may want to know through which of the slits the particle went. So what you do is you place a detector at the slits. And as soon as you do that, the particles no longer form the interference pattern, but they form the traditional two-line pattern. That's strange. So if you change the way you look at things, the things you look at change, as if these particles are somehow sensing that they are being looked at. Now there is an even weirder experiment done, it's also a little bit controversial, so think of it what you like. It's done by the physicist Dean Radin, and he placed people in a room next to the room where the double slit experiment was going on. And he asked these people to focus mentally on what was happening at the slits. And according to his results, to a minute extent, but statistically measurable, this would skew the results a little bit. What we also have is so-called random number generators. They are sometimes dependent on radioactive decay, because that's a purely random process. And in radioactive decay, subatomic particles are formed. Now there's a very interesting thing which happened at the 9/11 event, when a lot of human emotions were involved. At that moment, the random number generators all over the world started to generate pattern. So the numbers were no longer generating mere randomness. So this is a strange thing, because it looks like that these subatomic particles somehow can interact with our emotions, with our consciousness. Now if that is true, then either they must be made of the same medium, consciousness, or at least they must have a medium in common with consciousness in order for it to interact with that. And that leads me to my so-called pan-computational panpsychism hypothesis. So in this hypothesis, everything, as I explained, is informational. And matter is a special form of information, which is a standing wave, which is self-generating, self-sustaining, and a self-referential feedback loop. And then there is also this additional notion that whenever we see such a self-generating, self-sustaining, self-referential feedback loop, there might be something like sentience or consciousness going on. So wherever we look in existence, we see informational exchange between humans at the social level, between animals, between plants, between cells, between organs, within cells, between molecules, between atoms, and between subatomic particles. And when subatomic particles exchange information, they thereby also alter their mutual nature. And perhaps the whole of reality is a huge information processing system. And that is a little bit a strange idea, because it is made of information, but it's also processing information. Whereas the computer simulation hypothesis supposes that there is some higher reality above us that generates this informational world. So the processing of the information is then done at another level. But here we have an idea that it's information that can process itself. So it's a self-modifying feedback loop in a certain way. Is that an absurd idea? Well, in fact not. Because I have been speaking about the RNA molecule, which is one of the most fundamental molecules that make up life. And there are certain RNA molecules which can fold back onto themselves, just like the Ouroboros. And they have a part of them which is actually the reader, and they have a part of them which is code which is being read. And when a match is found, this gives a signal that something has to be done. And many different things can happen. And in this example, a part of the molecule is cut off. This is the so-called self-splicing RNA molecule. Now that is very interesting, because here we have something which is code or map, and territory, which is represented by the map at the same time. And in English there is this saying, the map is not territory. But here we may have found an example of where the map actually is the territory. And it reminds me of a story by the Argentinian writer Borges. And he wrote about a country where the science of cartography had arrived at such a level of exactitude that they had made a map with a scale of 1 to 1. So every object on the map was as big as the object in reality. And here we go a step further with this notion. Here the objects are made of the material of the map. So it's actually a kind of paper in which you fold a chair, and that is then also the chair. So the map becomes the territory. And it's again like the Ouroboros, the snake that bites itself in the tail. And every time I do this, because in meditational techniques you learn these hand mudras, and they are also indicative of consciousness. And whenever the index and the thumb touch, there is this awareness of that arises, this consciousness. So with all this information, we then arrive at the crazy title, this crazy subtitle of my book, of Transcendental Metaphysics of Pan-Computational Panpsychism. Because it is transcendental in the sense that it transcends the traditional dichotomy between the physical and the metaphysical, because everything is informational, and informational has a physical and a metaphysical component. It's also pan-computational in a sense, because every information exchange process in reality is some form of information processing. And finally, it is panpsychic if everything is sentience. And of course I am aware this is merely a hypothesis. I'm not saying I believe this to be the truth, but it's an interesting hypothesis to test for. And why is that so? Because we want to know more about this idea of computer simulations. And if you have this idea that we are living in a computer simulation and that information can only exist if it is encoded by something above us, well then you can ask yourself, but that reality above us, that's also informational, and how is that then encoded? And that leads to a tower of turtles, a so-called infinite regress. And you don't know where the base reality is. So in order to get a base reality, you must somehow have information which can recursively self-modify itself. So information which generates information. So I know you're all involved in the patent business, and in patents you often read incorporated by reference. Now what is reality doing? Reality is self-incorporating, self-embodying itself by a self-referential feedback process. And with that statement, I have come to the end of this talk. I thank you very much for your attention. Now, if you want to go for lunch, you can do that, but you can also stay in this room and ask me a few questions if you want. So those who are in a dire need of having lunch, you can go, and the others, please stay. I would be happy to answer some questions.
Yeah,
Graham.
I hope I've understood this. That if there's some degree of consciousness in stuff,
Yeah.
is it one consciousness or several or many?
That's an interesting question, because in the Eastern religions, like Hinduism, Buddhism, it's always said consciousness is one, it is not divided. And of course I don't know the answer to that question. The only thing, and that's why I also didn't say, yeah, well, consciousness arises. I said consciousness is involved. I said consciousness is involved whenever this self-referential, self-sustaining feedback loop happens. So maybe it's part of one consciousness, or maybe every time that happens, a kind of individual awareness arises. Because we also experience some kind of individual awarenesses. And maybe that's part of one higher consciousness. It's something I can't answer. But both possibilities could be possible. And this is, of course, open to more exploration. There's also one little anecdote I would like to tell, which I actually wanted to tell in my talk, is that when I was younger, I loved to read comics. And in one of these comics, there was a people called the Eternauts. And the Eternauts had pierced all the secrets of the soul and almost all the secrets of matter. And in Hinduism, the soul is often equated with consciousness. And it's one consciousness that encompasses everything. And I was thinking, what if the secrets of the soul and the secrets of matter are one and the same secret? What if this, and that's how I got this idea, that this same self-sustaining, self-generating feedback loop may be an explanation to both matter and consciousness. Yes?
Your hypothesis involves that information generates information, so pattern generates pattern.
Yes.
And now you've shown the formula for entropy from information theory, and this one also corresponds to the entropy in the physical world. However, the theory there is that entropy in the universe is increasing over time, and at some point everything will be random, so pattern is getting lost on the way.
Yeah, yeah.
And I'm wondering about this contradiction between the two. And
well, the less pattern you get, the more information you get. Huh? That's also an ID. And actually, Shannon's law of information is not exactly the same as the entropy law. Let me get back to that, because there is a minus in the equation. Here we have a minus, and that's why it's also called negentropy, negative entropy. And there is a relation between entropy and information, it's for sure, but it's not one-to-one. Whereas Boltzmann's entropy law is W, that's the probabilities of a certain states arising, is, or entropy, sorry, S is K ln W, and W is the probability, Wahrscheinlichkeit, that a certain state arises, and there is no minus here. So the amount of entropy which is more a measure of randomness, and information are negatively correlated. And there are also theories that we are living now in a time where the information content is steeply rising. And this is actually a sign to certain people, certain believers, that we are nearing the end of times, because as the information is going up, everything is getting more and more random as well, it seems, but somehow it's compensated by this huge rise in information that we are generating. Those are interesting things to explore, but information and entropy are not one and the same thing, but at a certain point, because the formulas are so similar, somebody told Claude Shannon, be bold, call it entropy, call it informational entropy, or call it necentropy. And he did that, and with that he also created a lot of confusion, because the terminologies are not 100% coinciding. There's a slight difference. But is that a sufficient answer to your question?
What about time? I understand the topics is there's physics and there's consciousness. By trying to approach them together, somehow, isn't there a bias introduced in the notion of time? And physics has a lot to say about time. For instance, reversibility of time. There are things which are reversible, others not.
Yeah.
And also time just as a dimension, not something particularly special, but just a dimension. And so in our own way of thinking as humans, we tend to see time as what we perceive as time. But there are also inputs from physics that tell us, no, time is maybe something different.
Well, with regard to this, I once read in one book written by a digital philosopher that time is actually the period of self-convolution. You have this feedback loop, and once it gets back to the origin, then you have, let's say, one period of time. And time is somehow something which is generated indeed by the cyclical nature of this self-referential feedback loop principle. Now, with regard to consciousness, and I have spoken that there are different levels of consciousness, perhaps. So you can be aware of an object or of a fact, and you can become aware of your awareness itself, and they are not entirely identical. So I think that time is involved in the object awareness, and it's also in these quantum mechanical experiments. It's somehow suggested that an observer is needed to make waves collapse into a particle, and so that consciousness is somehow involved in the processes of waves turning into a particular state. So somehow they are connected, and perhaps there is a higher level of consciousness per se, consciousness as such. And then there are these individual type of consciousnesses that the subatomic particles have, that we have, this individuality, and perhaps it all hangs together. From here, a kind of unmoving point, and here all kinds of points that are like bullets on strings that have a kind of rotational period, and they all have different types of rotational periods, and they interact with each other, and they experience time. But perhaps at a purer level of higher consciousness, there is no time. But that's mere guessing, and that's also making reference to some ideas from Buddhism and Hinduism, and I frankly don't know. And time is extremely complicated, so...
Yeah, because I mean, in the approach, by taking consciousness somehow as something which does exist, I mean, there's somehow already somehow a premise which may be conflicting with what we see from physics, in the sense that it implies a sequential idea of time, and which may not fit with actually what is observed, to also to the fact that it cannot be, there's nothing to get rid of probabilities. I mean, there's this famous experiment in the 60s from Alain Aspect about this Einstein idea that somehow at a certain level there could be a reality which doesn't have probabilities, or which has less probabilities, and this has been proven to not hold, and that these probabilities have to be there, and they are the hard probabilities. They are not just illusions, and things may seem logical when you look at it. Any random pattern can be seen logically, actually, and if you look at the specific days, what comes out as random on that day, you can analyze and see it's not random a posteriori, but it may still be generated at random. And the idea of that probability cannot be removed at all also leads to the fact that
there's no determinism.
Maybe afterwards it seems logical, but at the time things happened, they were not. They were purely random.
That is also a matter of perspectivism, as I talked about in my previous talk, and perhaps we do not have the right perspective on that, and we are here in our dimension of the physical world. We are looking at events among them, but we don't have the overview of it all. And it can well be that we are embedded in a kind of higher, all-encompassing consciousness. I don't know, it could be, and that would go more in the direction of what you're saying. But what I am more or less suggesting is that this individual type of consciousness, the more the object type of awareness, that is something that involves a kind of feedback going on, and sensing is also kind of resonating, and particles resonate, and in ourselves we also have resonance going on. If you listen to music, you can feel that. You can feel it in your spine. You resonate with music, and actually somehow this music is almost metaphysical. It's beyond time. You can put the same piece at every time, and every time have the same emotions coming up, and it seems to go a little bit beyond the traditional physical things, but still there is resonance occurring. So these are very interesting things to explore, and time is extremely difficult, and I wouldn't dare to burn my fingers on that topic, so I'm not even sure I want to, but it requires more exploration. But with this talk I wanted to indicate that, well, whenever you have resonance which can keep itself resonating, there may also be something like sentience involved, and this is perhaps not exactly the same thing as what is considered as a God consciousness in the different religions, or as a higher consciousness. It may be something different, but it is a form of sentience, and therefore it's definitely something that derives from consciousness. Jan.
Having listened to you, I'm wondering if we ever will get any further, because understanding, like what you said, like if I look at something, this something might change its shape, so I can actually not look behind what was there before, or like with Gödel, there will always be some uncertainty. So what do you think? Are we going to get any further? I mean, well, like with theories maybe, but will we be able to prove something or to?
Well, we can perhaps get further with this digital physics framework, and of course it will remain a probabilistic description. So you can never, like with the Heisenberg relationship, you can never pinpoint at the same time the speed and the direction of the particle. But at least you will have a framework that does describe all the phenomena happening, and at least if it is true that we are in some kind of informational substrate, I think we have already taken one additional step and placed knowledge on a little bit more solid foundation than what we had before. But as I said, digital physics is also still under development, and perhaps you are right, perhaps we will never arrive at a theory that really is a theory of everything, because, and also as you said, everything is in a certain way probabilistic and in a certain way has randomicity to it. So yeah, it will never be a deterministic universe. No, it is not. But that knowledge we have already found out, and that's already a solid piece of knowledge, that the universe is not 100% deterministic, but it is deterministic to a great extent because if you have a mountain, you have certain valleys and certain pathways where things can roll. So for instance, I am here on the top of this mountain and I throw a ball, and the ball will roll through these so-called creodes, which are a little bit lower than the rest. And this is actually what is happening with determinism versus indeterminism. It is indeterminism that it can still make all kinds of meandering movements within the creodes. So we don't know exactly where the particle moves and how it will move. It will move along the creode, but we are sure that it will stay within the limits of that creode. So nature is partially deterministic and partially interdeterministic. So we can't know things for sure, but we can know things to a great extent. Well, any other questions? I think this is it. Thank you very, very much for your interesting questions.
Thank you very much. So, if anybody would like to join for lunch, to ask even, on the, this one?